Hi everyone. So I figured I would make a video for today since we're not meeting live at all. I am going to go over number 8 in your packet. I told you could stop at 7 for the work that was due today. So I'm going to go through number 8. And then in today's assignment, I'm going to go through a few that I picked out. There's 12, I think, altogether. And I think I'm going to do like 4. So there'll be 8 for you to do. Okay. So, on number 8, we are given that FEC is a right angle, and we're trying to prove that 1 and 4 are complementary. So we're given FEC is a right angle. We're trying to show that 1 plus 4 equal 90. That's what complementary means. So let me just close this door because my dogs are crying. Okay. So anyway, if you think about if this is a right angle, I'm just going to go through like my thought process here. So I know that this is a right angle, which would make 1 and 2 complementary, right? We're trying to show 1 and 4 are complementary. So notice that 2 and 4 are vertical, so those are equal. So basically, if I can say that 1 and 2 add to 90, and then get it to say 1 and 4 add to 90, then I can say that 1 and 4 are complementary. So I kind of always try to make a plan. I get that this is hard for you guys and you might not know enough or like be confident enough or really know where to start to make a plan. So what I suggest, if that's you, is at least just start naming things that you know are true. Like, for example, well, we know this is given. We already did that. Since FEC is a right angle, like what can we say about FEC? Like, well, what is a right angle? It's an angle whose measure is 90 degrees, right? So we can say measure of angle FEC equals 90. I know that for sure, right? And why do we know that's true? Because we know the definition of a right angle. Okay. What else? I know that I want it to eventually say 1 and 4 are complementary. So think about like what you would have to say right before that in order for you to conclude that 1 and 4 are complementary. So I know that I probably am going to have here that the measure of angle 1 plus measure of angle 4 equals 90, right? That's how we could determine that they're complementary. So we need to get it on there somewhere that some angles add to 90. So we can't go straight to saying 1 plus 2 add to 90, even though it's obvious that they do. What we would first have to do is use angle addition and show that 1 plus 2 equal FEC. And then since FEC equals 90, we can say 1 plus 2 equals FEC. So let's get started. I know it's a lot. So like I said, I'm going to say measure of angle 1 plus measure of angle 2 equals measure of angle FEC. And that's angle addition. Okay, now since FEC is equal to 90, I can plug 90 in here and say measure of angle 1 plus measure of angle 2 equals 90. And that would be substitution. Okay, now why did I just say that 1 plus 2 equals 90? Well, then I can say that 1 and 2 are complementary, right? Or actually, we don't even need that. So I just kind of how am I going to explain this? So there are multiple ways to do this. I just kind of was realizing in my head that we could kind of use like congruent complements theorem, but I'm going to do it a different way. So ignore what I said about saying 1 plus 2. I mean that 1 and 2 are complementary. So we're going to say 1 and 2 equal 90. Now we know 2 and 4 are congruent, right? So my goal is what I'm going to end up doing is I'm going to replace 2 with 4 since 2 and 4 are equal because they're vertical. So I'm going to first say that angle 2 is congruent to angle 4, and that's vertical angles theorem. In order for me to substitute one out for another, I have to say that their measures are equal, which is definition of congruent angles. Okay, now that I have it in the measure form, I can swap one out for one another. and say that the measure of angle 1 plus measure of angle 4 equals 90. So do we see how now, since 1 plus 4 equals 90, now we can say that they're complementary. So sorry I was a little bit all over the place explaining this. I halfway through started trying to do it a different way than what I originally planned. So anywho, this is substitution and then definition of complementary. Okay, hopefully you were able to follow that. Okay, so that's that one. I'm gonna switch over to the packet for today. And I picked a few out to do for this. So we're gonna switch to this packet. I'm gonna do number 1. Since we haven't done any that had numbers involved, I'll show you number 1. So we're gonna restate the given. So hi equals 13. ij equals 13, and then ij is congruent to jh. So that's all given. As you're doing these, I think I've said this before, it makes it a lot easier to read if you number them. Okay, so let's see. hi is 13. I'm going to label the picture so I can brainstorm a little. ij is 13. We were given ij is congruent to jh. We're trying to show that these are congruent. Okay, so that's not too bad. So basically what I'm noticing is if these two, they both are equal to this one, they're going to end up being equal to each other. So we're probably going to end up doing some transitive here. I noticed that hi and ij are both equal to 13. So let's first state that hi is equal to ij. And that's because they're both equal to 13. So now they're equal to each other. That's transitive property. Okay. Since I have hi and ij in the measure form and ij and jh in the congruence form, you can't like mix the two. So I'm going to switch this to the measure form so that way everything is in the measure form. So ij equals jh. That's definition of congruent segments. Okay, now that they're both in the measure form, now I can do transitive because hi and jh are both equal to ij. So now they can be equal to each other, which is pretty much what we're trying to prove. We just have to put it back into the congruence form. So we're going to say hi is equal to jh, and that is transitive again. And then lastly, we can do the last step. hi is congruent to jh, and that's definition of congruent segments. Okay, so there's that one. We hadn't really seen one with numbers involved, so I wanted to do one of those. Number 3 is just like that, very similar. Number 2 is not. That will involve some segment addition like the one we did and the other day. Okay, so there's number 1 completely done. We are now going to flip to number 6. So there are a couple that are kind of similar to this. I actually think you guys probably don't need me to do this one, but since there are a few, there's like one other one that's just like this, I figure I'll do one of them. Okay, so we're given that 6 is congruent to 7, and we're asked to prove that 5 is congruent to 8. So I think there was one like this on the packet that was due today. But basically we have, we can do some transitive, right? 6 and 5 are congruent. So we're 7 and 8 by vertical angles theorem. Okay. Notice that 7 and 5 are both congruent to 6. So now they can be congruent to each other. And that's transitive. Okay. Now 5 and 8 are both congruent to 7. We're trying to show that they're congruent to each other, which we can do now by transitive again. And that's it. Not too bad, hopefully. Okay, so there's number 6. We're going to talk about 8 and 9. So 8 and 9 are kind of similar. I just want you to know for 8 and 9, if you notice, it says prove 1 is congruent to 3. 1 and 3 are vertical. You cannot just do vertical angles theorem and call it a day. So for 8 and 9, you cannot use vertical angles theorem. So I'm going to write a little note here. Do not use vertical angles theorem. And the reason why is these are kind of like proofs of vertical angles theorem, like why vertical angles theorem works, if that makes sense. So you're not going to use vertical angles theorem at all for these. These can be done in the same exact way. There's actually 2 ways you can do it. I was going to do one of them, but I feel like I want you guys to try these. I want you to try to do one of them with congruent supplements theorem. They can both be done with congruent supplements theorem, or you could also use like substitution and subtraction for one of them. So that's how I would do these. I would do one with like substitution and subtraction, and I would do one with congruent supplements theorem. So I'm going to put a note at the bottom of this. Try proving number 8 or number 9 with congruent supplements theorem. I know we haven't really used that yet, but there's one on the back that I'm going to do using congruent complements theorem, and it's kind of the same idea. Okay, so now if you go at the back, we're going to do number 11. Okay, so it says angle A is complementary to angle ADB. So A and ADB add to 90. C is complementary to CDB. So these 2 add to 90, these 2 add to 90. DB bisects ADC. So think about what that means about these 2. So we're going to restate all of the given. I'm just going to abbreviate a little bit so it doesn't take all day for me to write this. All right, that's a lot of given. Okay, so all that's given. I'm first going to deal with the bisecting. DB bisects angle ADC. If you remember, bisect means to cut in half. So that would make these 2 congruent. So we're going to say that angle ADB is congruent to angle CDB. And that's definition of angle bisector. Okay, so notice that A is complementary to this one. C is complementary to this one. And these 2 are congruent. So remember that congruent complements theorem says something like this. And it might be exact because I've been doing this for a long time. Like that day in class, I recited it exactly. It's 2 angles that are complementary to the same angle, or congruent angles are congruent. So this would be the or congruent angles. So we have 2 angles, A and C, that are complementary to a pair of congruent angles. They are forced to be complementary. Oh my gosh, sorry. Rewind. They are forced to be congruent. Let me say that again. Sorry, I might cut that part out. A and C are both complementary to a pair of congruent angles. So it forces A and C to be congruent. So if you think about it, I'm just going to make up a number. Let's just say ADB and CDB were both 50. If A and C are complementary to them, A is going to be 40, right? Because 40 plus 50 is 90. C will also be 40 because 40 plus 50 is 90. So see how that forces A and C to be congruent? They'd both be 40 if these were 50. So that's congruent complements theorem. So we can just go straight to saying that angle A is congruent to angle C. and that's because of congruent, complements theorem. Okay, so I think that should be good. I want you guys to try the rest. So I said I was going to do 4. I ended up doing 3. A lot of these aren't super long. This one is probably the longest one. You might need another sheet of paper for that one. So sorry in advance. Remember that this upside down capital T means perpendicular. Keep that in mind. All right, I think that's it for today. So this video is already way longer than I wanted it to be. So if you have any questions, feel free to email me, or you could come for ACT Lab on Friday. On Friday, I think I mentioned last time, we are going to have a short quiz. It's going to have the statements given to you, and you have to give me the reasons. There's going to be 1 angle proof and 1 segment proof. All right, that is it. Have a great day, guys.